So first, to find the initial or the velocities of the vehicles after the collision, we use the formula v squared equals v naught squared um, plus 2 times acceleration times delta x, and that allowed us to find the velocity of the SUV after the collision to be 2.3 or 2.83 meters per second, and for the wagon to be 12 meters per second. After finding those, because we know the velocity of the wagon to be 0 meters per second initially, we can then solve for the initial velocity of the SUV, and what we get is 10.83 meters per second. To figure out the type of collision we had, we used the kinetic energy formula, and by solving for kinetic energy and then using this equation here to solve for the percentage, we got 11.32% difference between the kinetic energies before and after the collision, meaning that the collision was inelastic.
Energy bar diagrams are used to determine the change in energy. In this energy bar diagram, it's the SUV before the collision and immediately after the collision. Before the collision, the SUV had no potential energy because there was no height, because he was driving on the road at ground level. He had 175,933.35 joules of kinetic energy before the collision. After the collision, there's still no potential energy, and there is now only 12,013.35 joules of kinetic energy. The difference done and the energy transfer is shown in the work done by a non-conservative force. If you subtract this number before the collision and this number after the collision, you will get the difference done by the work done by a non-conservative force, shown in this, negative 163,920 joules. For the wagon, there is no potential energy because the wagon was at ground level, and there's no kinetic energy because he was at rest, not moving, at a stoplight. When the wagon gets smashed in the back, there is now 144,000 joules. The work done by non-conservative force is 144,000 joules as well. For the system, we added both kinetic energies from the wagon and the SUV together. There's no potential energy because both cars are at ground level. For the kinetic energy after the collision, we added both kinetic energies after the collision and came up with 156,013.35 joules. If you subtract the kinetic energy before the collision and the kinetic energy after the collision, you will get the difference of 19,920 joules. This is the work done by the non-conservative force.
Force time graphs show the impulse or the change in momentum. The area under the graph is the impulse change of momentum. Both the force time graphs of the wagon and the SUV are the same because momentum is conserved. For the force time graph of the system, the there will be no impulse because momentum is conserved. So, since momentum will stay the same and not change, it will be zero and no slip.
Based on the information given, the motorist in the Escalade was speeding, going 39 kilometers per hour in a 35 kilometers per hour zone. If there is any evidence that shows the driver was distracted or following too closely, then the motorist could be fined even more. Besides this, if the driver of the Escalade did not have insurance or injured someone in the wagon, they could be sued.